Hello everyone, I'm Deidre Falk, and today I am talking about my project trying to answer the question, can no reference image quality assessment change how we assess images? I will be going over my original research approach, which has slightly changed, and I will also go into what my initial results have been and how this project will progress in the upcoming weeks. So first I will be starting with the introduction of my project, but also be going into what has changed over the past few weeks and what my current proposed project is now. So, first thing I will talk about is my previous project and what my original research approach was. So I was trying to focus on no reference image quality assessment, and the overall goal was to create a place to have a testing pipeline for no reference image quality assessment, which as which I have gone over in the past, but is no reference image quality assessment is one of two popular ways you can do image quality assessment. And by creating this testing pipeline, I was focusing on three papers. And in this pipeline, of course, you will be able to test all three of these models within one specific place. So the titles of these papers were Deep Neural Networks for No Reference and Full Reference Image Quality Assessment, No Reference Image Quality Assessment via Transformers, Relative Ranking, and Self-Consistency, and then SER-FIQ, which is Unsupervised Estimation of Face Image Quality based on Stochastic Embedding Robustness. And then all of these papers, of course, deal with no reference image quality assessment. All were trained with the most popular image quality assessment datasets, such as the original live dataset and the TID 2013 dataset, which I talked about in my previous presentation dealing with my project proposal. But however, the SER-FIQ paper has to do with face image quality data. And what this means is that all of the data it is trained on has to do with image quality assessment data, but also has the additional requirement of having all the photos being faces, which I'll be talking about a little later, but it was one of the problems I ran into when trying to develop this project further. And then this research project was focusing on using these papers and their code associated with the papers to create a platform where you can, of course, test all these three models. And this was an ambitious project and one that could take how we assess models specifically in the image quality assessment community to a new level. Because before this, um, when you were testing these image quality assessments, you would have to do this in like multiple places. You had to download like the first paper's code and run that and get results. And then if you want to look at the second one, excuse me, you would have to find where the code is for that one and then doing that as well. And that took much longer. So what I was trying to do is make one place where you could look at all three of these models in the same place. Um, However, there were some unexpected and insignificant problems when starting to dive into the project more, which led me to take a new direction. So, what are some of these change of plans when I was doing more research? And with the papers, I researched the code specifically, and all of them are specifically trained on certain data sets without a lot of room for expansion. Um, while going through the GitHub pages of these papers, a lot of the code was older than 5 years, and sadly, the models weren't very well documented. This would be fine if I had more time, but since this is a fixed link project, I wanted to make sure I had something that could definitely be done in the time span that we have available to us. There was also a problem with the paper no reference image quality assessment via transformers, relative ranking, and self-consistency because that code was created to run on the platform Ubuntu Linux. And even with it being possible to transfer that to Windows, once again, I couldn't do that in the time that we were given, and I would rather have a model that I know could run on Windows first, because that is the OS I have available to myself. And then the final problem I ran into when looking at these papers to code was when looking at the model that focuses on faces. I'll go back and sorry, this last one here. It was very hard to find a data set that that worked for both of the two requirements that I stated earlier. There are image quality assessment data sets, but there aren't many that focus mainly on faces as well, and that was what was needed in that specific model. So because of this, I have found a new research paper and project with code that will allow me to start a new project that will still be beneficial to the image quality assessment community in regards to a new data set that can be used to train a different model. So, what is this paper that I have found? It is called Rank IQA, Learning from Rankings for No Reference Image Quality Assessment. This paper, in a very general overview, is a new way of addressing no reference image quality assessment. And this new way is by using rankings when working with no reference image quality assessments. The main problem that can come from working with image quality assessment models is that the data set size that you need is limited, and there aren't enough data sets out there to really train these models. There are some very good ones out there that we all know about that I talked about earlier, like the original live one, and the TID 2013. But the only problem is there aren't much more, and they aren't like if you go through all these different datas, all of these different models, they all are trained on the same data set. So to address this problem, this paper, the researchers trained a CME's network to rank images in terms of image quality by using synthetically generated distortions from which relative image quality is known. This also means that these ranked image sets can be automatically generated without laborious human labeling, which is probably the biggest problem is trying to label all these image quality and getting people to say how well they think this image quality is. It takes forever. So making these data sets is super labor intensive. So with this, they have been able to make it that the computer can automatically do these distortions. In addition to this training and testing, this model also does the typical training and testing in regards to image quality assessment with the most popular data sets that I talked about earlier. And then I'll talk about this in the future, but this project uses two different ways of training and testing. And another great part of this model is that on GitHub, all of the training and testing is shown through examples. And there are steps that the author lay out for how to train the models with new datasets. And this is exactly what I need to do. I want to train this with this new dataset that I'll be going into now. So, what is this new dataset? This dataset is called Live in the Wild Image Quality Challenge Database, created by the same people that created the original live dataset, the Laboratory for Image and Video Engineering at the University of Texas at Austin. A new dataset. Um, to accompany this new model, I will be working with this dataset will allow me to train this model with new data that hasn't been done before that I've researched and seen. Most datasets that are used for image quality assessment models are specifically tailored for the models, and most of the images are very pristine and are created under highly controlled conditions by introducing graded simulated distortion onto high quality photographs. But with this dataset, the lab also designed and implemented a new online crowdsourcing system, which they have used to conduct a very large-scale, multi-month image quality assessment subjective study. Because of this database has over 350,000 opinion scores on the 1,162 images, and it's been evaluated by over 8,000 unique human observers. And how this dataset is different is because the dataset contains wildly diverse, authentic image distortions on a large number of images, captured using a representative variety of modern mobile devices. So this means that each image was collected without artificially introducing any distortions beyond those occurring during capture, processing, and storage via a user's device. This is extremely unique to this dataset, and through my research, I haven't seen this anywhere else. And this is the type of thing that is exactly what we will be seeing more and more of in the future, but that model that I talked about earlier isn't trained on that type of data. So, this leads me to my new proposed project. This will be easier to accomplish with how long I have, but will still provide interesting and valuable results for the community based on this project. I will be training the Rank IQA model on this new live in the wild dataset to compare the results from previous training on the first original live dataset and TID 2013 dataset versus this new dataset that I have found. The main reason that this project could be helpful is because this new dataset represents more of a real world example of the imagery that needs to be assessed by models instead of the pristine images that are in previous datasets. Since this model is older as well, it can be valuable to see if these new datasets can still be analyzed and tested with previous models. Or does there need to be new models that are specifically trained and tested on this new dataset? This is something that is always changing. It's the typical question of like, do you create a more general model that can be trained and tested on different types of data, different types of data sets, or create a model that is specifically trained for a specific type of data? And this is what I will be trying to help answer, specifically dealing with the image quality assessment. So, what is my project hypothesis and goal? So for the hypothesis, I believe that training the Rank IQA model on a new dataset will produce worse IQA assessment results from the previous baseline model, but will give the model valuable data with more current images. And seeing these results will help make models that can go back into the past and get the original dataset, but also this new dataset, be able to train and test well on both. In regards to this hypothesis, I believe that because this model has only seen datasets that are specifically tailored for image quality assessment, when the model does see this dataset, it will produce worse results until the model has been trained with the dataset. This doesn't mean that the model is bad because of this, but there will need to be more training and potentially different training tuning to help get the best results from the model. So going on into our project goal, my goal from this project is to see how an older model assesses a new dataset. Because most datasets are created specifically for image quality assessment models, these photos are very specific with how the image quality is shown and what distortions there are. And then another goal that is a little more personal for me from this project is being able to learn about the process of getting models off of GitHub and running it on my personal computer. All the other times I've really worked with computer vision. It's been on like a work computer with like specific resources that I know can work. And with my personal computer, right now I don't know if I had enough resources to be able to run these. And this is something that I would like to test. But I would also like to see the whole process of finding the correct model off of GitHub, which I hopefully have already done. Getting the model to be structured correctly, the training and testing of the model, and then one of the most important things is learning from the training and testing and learning more about how to tune models to get better results. To what degree I can do that will be seen. This is something that will come with time, but being able to do this all by myself and learning through trying things will be incredibly valuable. So now that the introduction is complete, I'll be going into my design details for the baseline and my proposed project. And we'll be going through each building block for all of the architecture. So now I'll be going into the design details. So here we have two system architectures, with the top being the baseline structure that the original. Sorry about that. Um, so with the top being the baseline structure that the original model has, and below is what I have proposed as a new structure when working with this new data set. So if we take a look at this at the top first, you can see that with the baseline structure, there were two data sets that got fed into the Rank IQA model. And that model has a cafe framework, which I will go into further. And then after training on these two data sets, you tested the trained model with the separate data sets, and then the results are saved to a file and shown with the research. So my proposed model will be to at first download that structure, but then instead of using that model, I will convert it to PyTorch, which I will go into why I want to do that in a few slides. And I will also at the same time be downloading the live and the wild dataset and creating the correct file structure that was from the baseline with the live and TID 2013 dataset. So with this new converted model and this dataset that I made the correct structure for, feed that into this new PyTorch model with the new dataset. Train on that dataset to then test from a subset of that dataset. And then I will be compare the results of this proposed model with the baseline. And that will be how we get the results from my hypothesis. Alright, so what are all these building blocks that I will need to do? The first one is download the baseline structure and model. Before getting started with my proposed structure, I need to download and analyze the original model. This means downloading it from GitHub and making sure the structure off of GitHub and make sure that all of the files and structure of the model is correct and what is needed for implementation. Impressively, the model is very well documented, and even with the project being over 5 years old, all the documentation there is a lot of documentation which allows for easy implementation. This design is used to make sure we have everything needed to be able to compare our proposed project against. And this design will be the same as the proposed project, but I'll need to make sure that how the original authors have their file system saved is the same when running on my machine. Alrighty, so on to the next building block. Second, the first actual building block from the new proposed project is to download the new proposed dataset. With the new dataset from the Laboratory for Image and Video Engineering at the University of Texas at Austin, it is nice that there is a website that can be used for downloading the dataset. And then all 1,000 plus images were rated online by diverse observers, and those ratings are also available when downloading the dataset. And then these scores are fed through the model with the image path when looking at the image quality through the model. You'll see an example of this in the implementation phase, but that's how this data set is designed. And then the main design decision that needs to be made is already for me with this data set. Because when downloading this data set, everything is already made for me. The main thing is to make sure that all the images are saved correctly, and I also need to make sure that the mean opinion scores in the database are corresponding to the right images when saving a text file that needs to be fed into the model. This all needs to be done before going into the implementation of this building block. So, going into downloading the Rank IQA model for my proposed project. The Rank IQA model code is stored on the GitHub page, which can be downloaded to do more training and testing. The model is made with the Cafe framework, which is a deep learning framework that is made with expression speed and modularity in mind. Because Cafe is very popular, but with MATLAB and Python, I think it would be helpful to the community to convert this Cafe model framework into a PyTorch model framework, because it can provide the community with a simpler, more traditional model to use. I'll go into a little more detail about what Cafe is. Cafe is a framework that I've never heard of before this project. It is a framework that I think has been phased out by PyTorch and TensorFlow. I will need to go into more research of Cafe to see in which ways it should be used instead of the previous stated frameworks. Currently, I am leaning towards converting the original model framework to one of these more popular frameworks such as PyTorch or TensorFlow because they are more commonly known, and with that, I can have more support when working with one of these new frameworks. This design choice can come with potential setbacks though, because the conversion might mess up how the model is run, and this could cause me to be further behind in the overall project. However, I have chose this design choice because it will cause me to learn about how you can convert models to a different framework, and it would give me valuable experience in doing this. So, the second thing I will be needing to do after downloading that model is the actual conversion. Like previously said, converting the original Cafe created Rank IQA model to PyTorch will allow for greater reusability. And converting this model will also allow myself to have valuable knowledge of how to continue to use older models to a newer, more modern framework, which is very important when working with models created by the community. When converting this model to another framework, there will be a lot of problems, I'm assuming. But with this design, it will allow me to know more about the model when going into future building blocks. And using this design can be good instead of just using the framework given to me, because I have to learn more about the model when converting to another framework. So, after this, after conversion to a new framework, I can finally get into training. As well as getting the code off of GitHub, the specific model that is used is a pre-trained ImageNet VGG-16 model. This is a popular model in the computer vision field, and it's easier to use a pre-trained model than to train a completely new model from scratch. So with my proposed architecture, this pre-trained VGG-16 model will be trained on the live and the wild dataset instead of the original live and TID 2013 datasets. However, I will not be changing the pre-trained model that the baseline model used, because this is the model that is used to do the training on. There is no need to change whichever the pre-trained model is for what I will be doing on this project. There's also a choice of using a model from scratch, but the problem is that with this would take a super long time to train up, and the authors probably could just use that time to train and tune the pre-trained model. Because of this, I will be doing the same in my proposed project. This building block is probably the most important. This will determine how different the training is between the two projects we will be comparing. Training will be done with a specific split between the training and testing set because you don't want to train on your testing set. I think right now it will be an 80% training to 20% testing set from the new data set. This should be a good number and will allow enough photos for both training and testing. So going on into testing, the most important thing is that testing will begin when the training with the new dataset concludes. This also means I will need to subset the data, like I previously said, so that some of the data in this dataset is only used for testing. And then one thing I'm really thinking about is how to create a stylized and efficient way of displaying the testing results so that it is easy to understand what the results are, but it will also allow for the new block to be easily understood. And this is an important part of designing the testing phase. The main design element of testing this model with the new dataset will be determining how to display the results, like I said. I will need to display the results of training and testing. And right now, I think I would do this with the table that you usually see in research papers. Testing the model will be the same as the baseline project, however, the results might be different based on how well the training goes. This could be important because depending on how well the testing goes, I might need to go back into the previous building block and change how the training is done. A big design decision I have made is that I need to make sure that I don't overfit the image data we have. So when the model is done training and goes into testing, it won't just remember the image quality instead of actually analyzing the image that it is given. That is a classic problem with computer vision, and I will need to make sure that when training I have the right parameters so that this won't happen. So, going on into the final building block of my proposed project, and that is to compare the results between the two. In the original model, you get two different results from the rank IQA model. The first model input is the original ranked output of the images based on the image quality of the images. This is something that sadly I can't do because the datasets that they use to rank are specifically ranked datasets already. You can't use a original live dataset or the TID 2013 to do the ranking. So the output I will be getting, I will train is your traditional model output that produces common image quality assessment results. I need to design a table similar to the one on the right that allow me to compare between the baseline and my proposed project easily. So, after doing this, after you see all my design, so now it's time to move on to the implementation status and initial results from the proposed project. So, back to the baseline and my implementation and status on that. Everything within the GitHub repository has been downloaded. However, there have been some problems with the actual implementation of the baseline structure because part of the cafe framework is in MATLAB. This has made the installation of the model a little harder than previously expected. The baseline structure uses Python and MATLAB, which is the backbone of the cafe framework, to then train and test the baseline model. So, with the cafe framework having MATLAB backbone, this has made me take some time out of this project to learn about MATLAB, because I've never used it before. This has resulted in me having to download everything needed for Cafe and having to set up MATLAB to be able to use Cafe. With this, there have been some additional time allocated to learning MATLAB and how it connects to Python, specifically for this model. Cafe also being an older framework, this means that it has taken a little longer than I expected to get the knowledge of this framework before switching to another one. But once this is done, with how well the documentation is on the baseline GitHub repository, it should be an easy implementation of the baseline model to get up to speed moving into conversion of the original model to PyTorch or TensorFlow. So, you remember going back to the first building block, which was downloading the new dataset. The complete dataset is downloaded and ready to be used to be trained and tested on. The implementation of these photos will be done by feeding them through our newly trained model. And with the average mean opinion score for each image being provided as well in the dataset, I need to make a text file like the one below with the file path and correlated mean opinion score. I need to make sure that the mean opinion score for each image is also corresponded correctly because this is what is being fed into the model for training and testing. I also will be able to test out how this file works when using the baseline model and doing training and testing on that model. And the images that I'll be using will be from the original two datasets, the original live and TID 2013 dataset, but it will be in the same format for my new proposed project. So, going on into probably the hardest, most complicated step for this project, the conversion from Cafe to PyTorch or TensorFlow. With converting this original Cafe model to a PyTorch model, there may be potential unexpected problems from this conversion. Implementing this block will mean that we have a usable rank IQA model with the PyTorch or TensorFlow framework that can be used to train and test this new dataset. There is a potential that instead of converting to PyTorch that I originally will try first, I will need to try to convert to TensorFlow. But this sadly can't be determined until actual implementation. So during implementation of training, implementing this building block I believe will take the most time. It will come with unexpected problems that I won't be able to think of until I encounter them. I will also come it will also come with problems that won't be in the documentation. It might be too obscure to find somewhere on the internet. That is, of course, the worst case scenario, but I believe that implementing this step will require me to learn about the two frameworks I will be working with, and knowing what problems there are and how to potentially fix them. What I am excited about is that this will give me such valuable experience about the two frameworks, and I'll learn so much about how models can be converted, and if it is possible to convert, and what are the ways in which things aren't possible. For me, being someone who is really interested in machine learning and computer vision, this is the type of work that I would be doing in the field, and having this experience will allow me to know certain things I can and can't do for future projects. I have said that I will be converting to PyTorch, but it isn't a certain thing, and I might have to convert to TensorFlow or even just stay with Cafe. But like previously said, I won't know until I try it out. So, after the conversion is done, I can finally go into the training of this new proposed data or model. But then the next few blocks won't be able to be implemented until after the conversion of the model. So the status right now is just waiting on previous blocks to finish. And during the implementation of training, I will also be looking at how the training takes place in comparison to the baseline. Looking at the implementation of this training will mean to see how long it takes, how effective the training looks, and are there similar results from the training with the new model to the training results of the original model. During implementation of training the new converted model on this dataset, one thing that I will really have to tinker with is the training parameters and how much tuning I will need to be doing. This is where my machine learning engineering background will come to help me, and I think this is what I am most excited for when training this model with the new dataset. I will have to see how the model reacts to the new dataset and if there are any potential problems with the dataset. Implementation of this will also make me have to not follow the specific documentation given and make my own decisions on best parameters to train with. This will mean that I will have to train multiple times to make sure I'm getting the best possible results from the data without overfitting the data to the model. So going on into the testing part, the implementation of this building block will mean that the rest of the structure before this is working correctly. A lot of this building block will be looking at the results and making sure that the training of the model makes the testing efficient. Since this model will be new, I will also have to make sure that I can get the correct testing results that I can compare to the results obtained by the original model. I will be implementing the results and looking at the scores that were from the baseline project to the proposed project. This will allow for equal comparison between the two data sets, and if I find a better image quality assessment result to compare the two. The two projects, then I will do that, but right now I will be implementing the same tests that were in the original project. And then the last part is comparing the results. Then I won't be, oh wait, I went backwards, sorry. With this step of the project being when we see if the project hypothesis is true or false, this means that this is the final block and hasn't been started yet. Results that the original model obtained were linear correlation coefficient, which is LCC for short, and Spearman's rank order correlation coefficient. These will also be used in my proposed project to have similar and understandable results to compare between the two projects. So, finally, I will be going into my next steps for this project since there is still a lot of work to be done. To make sure it is understood, I will give a slight overview of what my project is now since I have changed. The current project is to use the Rank IQA model that was published in 2017 and train and test a new live in the world dataset on this model. Excuse me. This will allow me to see how an older model that was trained on specific data can be modified to work with newer data and to see to what extent it is feasible that an older model can use new data. And my hypothesis is that this model will have worse results when training and testing with this new dataset compared to the results that were attained from the original dataset. I am extremely excited about the potential results I get from this project. Either way, if my hypothesis is correct or if my hypothesis is wrong, it will provide myself and the image quality assessment community extremely valuable information about how older models can work with the new data. This data is data that is very important because it is changing how we assess image quality assessment models. And with images changing all the time, these models need to be future proof, and this project is looking into what needs to be done to achieve that. So my current timeline is having the first building block, meaning that the baseline model is set up and able to run with the two original data sets, and making sure that I have the results stored easily and reproducible. I will hopefully be able to complete this by the end of this week. And then by the end of the first week of November, it will be all about making sure that converting the original model to PyTorch or TensorFlow is completed. And then by the second week of November, I will have a model that can train the new dataset. Hopefully by Thanksgiving, the training and testing of the new model is completed, and I will have a great way of displaying the results from both models, allowing me to create a presentation and demo to have ready to be presented the next week. And hopefully by the end of November, I have the project completed with the project demo and project final reported complete and be ready to share. And that is everything. Here are my references that I had for the images and no, sorry, this is just the data set. That is everything. Thank you, and hopefully you enjoyed.